Hi, hello everyone. My name is Luca, and this YouTube series we're going to be learning a bit about OpenGL, essentially, and how to create this sort of post-processing effects. So this is a small game that I've been working on recently with a friend of mine. He did the art. I will link some of his work in description below the video. But anyway, here is the game and it's just some basic memory game. But what I wanted to do is give it a bit of flair or style, so I came up with this post-processing shader. And essentially, we're going to try and learn how to do this CRT-like effect. And for that, yeah, here we're going to use WebGL, and it's fairly similar to OpenGL. It's essentially almost the same specification. And for that we're going to be learning about essentially GL frame buffers. Right here, you can ignore probably WebGL if you never worked with web part. If you never worked with WebGL, what's important is GL frame buffer. And yeah, for the code, I already provide a code here. And in post-processing setup, we have part one start, and this will be our starting point, and I'm going to be explaining from this. Anyway, don't worry, I'll get back to it later. But for this series, you might just want to either clone it, or if you never use GitHub, you can also just download the zip file, and then be explaining a bit how to set it up. Yeah, we're probably going to need to use Node. Any version will probably be fine. Vite, I'll also cover that a bit later, and that's about it. Then we can start with our project and yeah, work on it. So yeah, anything else? Nope. That's it. That's it pretty much. So yeah, let's start coding. All right, everyone, let's start. So basically, you can either download the code or and then extract the code, or you can use Git and then just clone the code. Right? I have some folder here and here. I'm going to be cloning it. We can do. Sorry, command this in another window. All right, I'll be using Git bash, but you can probably use the Windows terminal as well. And then let's just do git clone. If yeah, copy paste buffer is empty. All right, git clone, bring this here. All right, let's see. We navigate YouTube series. Here we go to WebGL here, and then here it's start. All right, what I just did is basically navigated to this folder. All right, which you can also navigate like this, this, and then maybe open the terminal here as well, right? If you wanna, or you can just use this one if you navigate it like this. And then what we need to do is just run npm install to install our dependencies. And then come on, and then we run Vite. Vite is running on 5173, right? So blah blah blah. All right, this is the okay, and this is our screen, our game. So at the end of the video, we're going to have yeah, kind of funny. It already has a bug. So let me just fix this quickly. Yeah. All right. Let's move these guys a bit. So while I'm here, this is the project, right? And here you have a standard index HTML file. What's important is canvas element. So yeah, for those unfamiliar with browser, the canvas element, it's just used to render graphics. So in this case, WebGL graphics, and so here we can say 400, right? It will resize the canvas element, but we need 800. Yeah, I also added these images. They're just not displayed. It was a bit easier to load them this way, but you don't have to do that. You can probably load them via standard fetch, and you can see it's loaded here, the cat, but I'm not going to display it anyway. And here is the main code, right? So here, just a note. So this is imagined for beginners. So basically WebGL beginners who know some basics, right? Who know how to load some geometry, and then render texture. So basically, what you need to know is how to get this right. If you know how to do that, this is perfect for you. If not, then I suggest to maybe just wait for another video where I will be explaining WebGL basics and how to get to this. So, and here, let's just fix the bug first. So yeah, I wrote some functions which will help you. So basically here we have a draw quad function which just draws a quad. So quad is just a basic geometry or a sprite, whatever you want to call it. And then it renders textures, in this case K texture, and then in this case second one is fog texture, and then let's just move it a bit. And when you save, the width is going to automatically reload, and then everything is moved, right? Because and here, all right, perfect. So yeah, I suggest maybe pausing here and looking through the code a bit to get familiar with it. Yeah, you can just maybe change some stuff, see where it is called. But anyway, just to note, this is to do on purpose because we're going to be implementing our post-processing here, right? We're going to implement before mentioned WebGL frame buffer, and then we're going to take this screen and then just render some effect over it, and this will be our post-processing essentially, right? So yeah, that's pretty much it. Get familiar with code, and right after that, we'll get to coding. Right, sorry. One last thing that I want to discuss before we start coding is what we're actually going to have at the end of this video. And so basically we have our screen here, right? This is what we're drawing to screen. And by the end of this video, we're going to have this. Admittedly, it's not much, but it does allow us to set up everything so that we can work on our CRT shader or more advanced example of post-processing pattern. So this is fairly basic as an example. You might see it often in games where the colors are inverted, or maybe it's some kind of a red color or whatever, right? So this is just a grayscale effect, and I just wanted to discuss quickly how are we going to do it, and it should be fairly straightforward. So let's say yeah, we have our screen here, right? And here is our cat, here is our dog or fox. I don't remember anymore. But anyway, the important part is the screen. We're not actually going to render this to screen. We're going to render it to a texture. All right. So here, uh, text, right? We're rendering to texture, and then we will use that texture, but not yet. First, this is our screen now, right? All right, it's screen, and we're going to render a quad over screen. So here might be A, B, right? Corners of the quad, C, D. So basically we have some kind of quad, which we map to the edges of the screen so that the quad covers entire screen, right? And then we render the texture to quad, right? Yep, yep, yep. Since our quad is now rendered, it's filling this entire area, right? And but our quad has a shader attached, right? And to the shader, which is just basically a program on the GPU, we can write some code that's going to apply the effect, and then since our quad is rendered on screen, we apply effect to it along with the right first the texture, then effect over it, and that's essentially it. So basically, to recap, screen to texture. Discard this screen to texture, right? Texture to quad, and quad to screen, and it fills the entire screen. But we can also, just for example, what I might do is like draw quad here, so just that you understand it better. So it might be like this, but usually we're going to fill it over the entire screen. But I'm just going to show example like how to do it like this. Anyway, sorry for this kind of drawing. Let's start then with the code. And here it's fairly basic. We just have an index.html file which actually defines these images and image element, and then it also has a canvas element, right? So if you just remove this here, for example, you're going to see small image here, which I actually used to load it into into WebGL and then render everything. And canvas is just this element which holds basically the WebGL and its context. And then the main part is actually here. So what we need to do is actually implement post-process setup. And for that, we're going to start with some variables. So here, how should I call it? I had notes as well for this, so maybe yeah, let's just say here post process stuff. Yeah, that's good name, stuff. Post, and we're going to need yeah post process VAO, which is of type this type. So let's say what does it do? What does it do? It is a VAO which holds geometry for post processing. If you remember, I mentioned that we're going to have, if this is our screen, and then we're going to just render the quad over the screen. So here might be V1, V2, V3, V4, where these are the vertices of or edges of the quad, right? So we just render quad here, and to that quad we're going to apply, this was supposed to be here, we're going to apply a texture, right? Which will be our screen. Yeah, so yeah, sorry. We're not going to render the screen, we're actually going to render the texture and then render that quad and texture to the screen. Okay, let's see further. We might need, yeah, post process program. So basically, yeah, the program will hold shaders for our post-processing effect. So yeah, shaders. Then frame buffer. This is important, right? I mentioned that the frame buffer is object. That does what connects, that holds the texture to which we render screen, not screen, scene. All right, and then the texture itself, and that's of type WebGL texture. Okay, so in post process, we can actually start by defining our geometry. All right, let's see. So const data, new flow 32 array, and we're going to pass 1, 1, 0, and then 1, 1. So position, and these are x coordinates. So for those unfamiliar with WebGL, what position is, right here, let's say this is our quad that we had, and here might be position, in this case, since -1, up is in WebGL, I believe it's 1, and then this might be position, sorry, disregard this, it might be 1, 1, and this might be position -1, -1, and 1, -1, right? So we need to define those, and also we have a texture coordinates which define how to map our texture to this, actually how to map our texture in general, because uh, the graphics pipeline is going to interpolate everything correctly. We just need to say where are the edges of the texture, and texture coordinates are usually from 0 actually to 1, right? And so 0, 0 might be, and then 0, 1, 1, 1, etc. Anyway, it's not that important right now, so we just need to define it. Moment. All right. So let's do that actually. Let's say this might be v1. This might be 1, 1. We don't care about z, but we still need to define it. So that's why it's 0. And then this might be v2. And here we need a comma. Minus 1, minus 1. All right, that's for the vertices or edges of our quad, or we also need indices. And since we don't have a lot of indices, then they can just be single bytes. So first triangle and 0.3 maybe. Second one, second one. All right. So if you're unfamiliar, again, what we're doing here is these guys again. So we basically have our quad. Let's say v1, v2, v3, v4. But with WebGL, usually you can render either points, lines, or triangles, right? So we actually need to render 1, 2 triangles, right? And that's what this 0 might be, then 1, then we say this might be h2, but then we also need to render this one. So it might be 0, 2, 3, right? So what we're saying is just we're saying take this vertex, take this vertex, take this vertex for one triangle, and then we say what was it? Take this vertex, and take this vertex for the same triangle. All right. And then we're probably going to need the function that's going to actually set up our post processing. Create view, yeah, data, and let's define it here. So the first argument is data as float32 array, so our vertices, and then we're going to pass indices. Data as uint8 array here, and we're going to return, what was it, WebGL vertex array object. So let's see. Okay, we can start by actually creating the vertex create. Let's go create vertex array, and then we need to bind vertex array exactly. So the vertex arrays object is just an object that's going to actually hold a lot of buffers, and the buffers in this case, in this context, is just memory that we send to the GPU so that it knows how to render stuff to the screen. And first buffer that we need is actually vertex buffer, right, for our vertices. So this is positions and texture coordinates. It's buffer. Bind buffer. So what type of buffer it is? It is an array buffer, and we pass in vertex buffer. And then we need to actually send data to the GPU. All right, buffer, our data, and static row. It's just a hint to static row is just a hint to WebGL. It means we're not going to change our data during frame or during the rendering. And then we need to define stride. Stride is what is this stride? If you're not familiar with it, let me first I need to define it, right? Bytes per element, and then plus 2 times float32 array bytes per elements. All right. So to explain it, we're sending floats, right? And each float is 4 bytes or 32 bits, right? So what does it look like? Let's go here. So basically, we have our vertex, right? And for each of the vertexes, let's say our vertex, we have an x position, y position, z position, and then we have u and v for texture coordinates, right? U is x in texture coordinates, and v is just epsilon in when we talk about the texture coordinates, right? Imagine this is our texture. We need maybe here pixel that might be please move yourself. That might be something like let's say this one here is at texture coordinate 0.25 and 0.25, right? Because it's somewhere over here or whatever. And the stride just is this. This is stride. So exactly. Um, yeah, can I explain a bit better? Yeah. And we have 4 bytes here, 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 because all of them are float. So if you have some other kind of data, you might have a color, then the stride might be RGB, and then maybe 4 bytes here, 4 bytes here, 4 bytes here, or whatever you send. Usually we're going to send mostly floats, which are 4 bytes. So yeah, let's actually go further. We're probably going. I'm going to explain it a bit more, but let's just write here as well. So position vec3, right? And times size of float, and then we have text coords vec2 times size of float, for example. And then we need to describe our position so that OpenGL knows how to read our data. So we do the, what is it called, pointer, exactly. And then I'm going to explain this 0 in a second. It's not important now, but essentially we send 3 floats for position, right? X, Y, Z. Type is GL float. This is not important right now. Stride, we send stride. And we don't have any offset here because we start at 0 byte essentially. And then we just need to enable it. And then we need to describe texture coords attribute. And here vertex we have 1. I'm going to explain it in a second. We have 2 because we just have U and V, or texture coordinates. It's just a 2D image, so we have an X and Y. We don't have a Z. All right, GL float. We don't care about this. False stride. And here, this is a bit different. Times. Why is that? You might ask. Because simply, right? I mentioned here we already had, so the texture coordinates actually start here, right? U and V start here, and that is 3, right, for X, Y, and Z. We offset those and then just times 4 for the size of float. All right. then we need to enable it. And now is probably perfect time to actually write our vertex shader for this. So, and I'm just shamelessly copy and paste it, and then we can explain it. So, you might have noticed 0 here and 1 here, and those correspond to vertex shader. Location 0, location 1. Like we said, we use vector 3 type for a position. That's why we paste 3 here, right? X, Y, and Z. And then we use vector 2 for texture coordinates. Texture coordinates are pasted into fragment shader, so we're going to use them further to basically texture our geometry, and then here we just paste position. Yeah, that's it. All right. Like I mentioned, and this is not beginner friendly. So I will be making another tutorial for beginners, but here I do expect some knowledge about WebGL actually for this video. Sorry, but hopefully with the next videos, beginners might get back to this video and follow it further. And now just we need indices buffer, which will be GL create buffer. We need to define it. Yeah. Passing indices data and GL native draw. And then we don't want to override it on anything, so we're just going to say bind vertex buffer, and we're going to unbind it. This is how we unbind it in WebGL. All right, and here, of course, it's complaining because TypeScript. Here it says it returns WebGL vertex array object or null. Sometimes it just loves to complain because of how I set up TypeScript config file. Anyway, not important. So we have our vertex array object. Let's see, what do I need further? I probably need to create a texture, maybe. Oh yeah, let's finish our shader first. So set up shaders. So we have our post process program, and here create WebGL program, and here we're going to paste two shaders. Post process. Oh, nope, wrong. And here as well, we're just going to name them. They're already named post process. And we don't have for the fragment shader. Fragment shader. Now to shamelessly copy paste again, because I don't want to write shaders. I don't have IntelliSense here. All right. Let's see. So I mentioned that the texture coordinates are just pasted in. We get the texture coordinates sampler. This is just for the texture, so it knows where to sample from. Output color. So this is our pixel, and we're going to do grayscale. So this might look a bit confusing. So, but let's just Google it. Oh, weird. No. All right. Luminance weights or something like that. Let's relative luminance. Perfect. All right. What we're doing here is I'm using these values more or less, and when this is multiplied by our pixel color, we actually get luminance or how uh, bright something is. Basically, it's just to kind of a grayscale image. Anyway, it's not that important. What's important is it's probably important if you're into physics or something, but anyway, yeah, that's pretty much it. I just use some values, which will ends up in weighted value, and then we use it, right, to create all. So our RBG colors becomes weight, right, and then that gives us some nice grayscale image. All right, let's see what we can do further down the program. Oh yeah, we need to pass this to actually create a shader. This is fragment shader source. So that's it for the program. Further, we're probably going to need to create a frame buffer. Yep, let's create a frame buffer setup function. All right. And here we need to actually return our WebGL frame buffer. We need to create the frame buffer, then further, we're probably going to need empty texture for the frame buffer. Exactly, let's just set up a frame buffer texture here, and maybe I can just do this frame buffer. Then we have the frame buffer defined. I think we did. Frame buffer. Ah, of course, WebGL frame buffer. Because it can be null as well. Really annoying, but there it is. And then we're just going to use create texture, and what do we need? We need canvas here, and this is going to be fairly simple function. Create texture, and should I? Yeah, let's do this. Const text gl create texture. All right. We just need to bind it so that GL knows that we're using it, and it's 2D texture. All right, text as WebGL texture because nulls, and then we just need to say what kind of data will it have. So GL it's texture 2D. We don't care about level. We're going to use all the channels. This is canvas width. Canvas. We should probably paste canvas. HTML canvas element. Canvas height. And we don't have any data in it. So, and I have forgotten something. For sure. Let's see. Let's see. What did I forget? It has really lots of overloads. 0 All right, unsigned byte. Ah, yeah, this overload it's fine. So basically, we're going to use RGBA channels or all channels. It will be of size of the canvas. So because we need to cover, this is really interesting. We need to we're going to cover entire canvas. So the canvas is 800 by 800. So this texture will be as well. Usually, if you resize canvas, you want to recreate this texture. And the last parameter is null because we don't pass any data. Usually it's unsigned byte for the type. And I think that's fine for our texture. If there is a bug with it or anything, we can return back to it, and then we just return texture. And yeah, this is fine. We have created a texture. Now the frame buffer, and we probably need to bind it. Frame buffer. What are we binding? Frame buffer. We need to set up the texture now. All right, so that let's actually write it first, and then I'm going to explain it. Texture 2D here, frame buffer texture, and then just unbind it. No, we don't want it bound anymore. And this needs to be, of course, not the frame buffer, but actually this. All right, what are we actually doing here? Like I said, the frame buffer is just an object that calls multiple textures together. It might be also depth texture, stencil texture, or color attachment 1, 2, 0, blah blah blah. And what are we doing here? We're saying, okay, we have created the empty texture, and then just use this texture. And then when we bind a frame buffer object, so if we have frame buffer object here, the actual scene is going to be rendered to a texture that is bound to frame buffer. I'm going to get back to that later as well, but let's actually start. I just need to return it here. Yeah, I think we can start with our render loop, and that should be it. Or actually, we might don't even have to return it because we set it up here and it's globally set here. So let's just go with the draw scene. Exactly. All right then. Let's see. What do I need? What do I need here? Draw not the scene. We don't care about the scene. Right now we need to first bind the frame buffer because we're going to render into our frame buffer, or at least the texture attachment of a frame buffer. Draw to texture of frame buffer. All right. So what do we need? We're going to clear the contents. Clear the color of frame buffer. All right, that's fine. Then let's see this. Our scene is now drawn into frame buffer. Okay, we don't need it anymore. So WebGL frame buffer. So draw to screen buffer. Perfect. And then let's just clear it as well, or just shamelessly copy paste it here. If I manage to do that. And then we need to bind our geometry, which we defined, that covers the entire screen, right? Just we need to know we need to use eventually post-process program. So those are our post-processing shaders. So this will be essentially just color our quad and texture with the grayscale, right? We're going to have our scene, and then our scene gets dot multiplied by our values, which will result in kind of grayscale image. And then just we need to also say bind the texture. So here, texture that's bound now is our frame buffer texture. Exactly. And then we just need to draw that quad, which is triangles, 6 vertices, GL unsigned byte. If you remember, we used unsigned byte for our indices, and then the offset is 0, and that's fine. And this should probably work. And of course it doesn't. I'll get back to it. What does it say? Draw element is section map dimensional format. Ah, okay, all right. I need to define where is our texture. What do I need for the texture? Probably needs map format setup. I'm not going to go into details here. I'm just going to define it. GL texture 2D GL texture min filter, and it can just be GL nearest. Mag filter. Okay, yeah, that's it. Perfect. So min and make filters are just say to OpenGL what to do when texture needs to be resized up or down. Anyway, it's not that important right now, but what's important is this is our grayscale image, and if we try to uncomment our code that renders to frame buffer, so this would be it, and this part. All right, we have our original image, and if I bring it back and then save, we have our image. All right, once more, so just that we're sure. Actually, I need to do it from here. All right. So yeah, that's how it works. So just to recap with this effect, which is basically a grayscale effect. But in the next video, what we're going to try to do is this kind of effect, which is a bit more involved. We're going to have to use multiple textures for it, because this vignette, for example, effect, that is a texture, background noise is a texture, but it's scrolling, right? So it gives us this animated kind of effect. And we're going to be playing with it a bit. Anyway, just to show up a game without the effect, if I use none, it just looks like this. So as for the game art, friend of mine did that, and I will link some of his work in the description below the video, or just links to his profiles. But for the game itself, I did the programming, right? Yeah, so we also have, I also did this kind of effect, and this one I'm not so proud about because I imagined that it would look better, but it does not. But there you go. Anyway, so this is for next time, and I also just wanted to mention the beginner series that I was kind of planning to do, and I will do it. It will be just in different format. I will probably do a game, and we're going to be using WebGL to power up that game, right? To do the rendering, and the other stuff we're just going to use regular JavaScript APIs. But for the rendering and game will be probably more focused on WebGL part, because there is a plenty of game tutorials, and the JavaScript is not that hard of a language. So it will be really focused on more on WebGL and some intricate parts of maybe game development or just graphics in general. Anyway, that's it. Hopefully you enjoyed this video, and hopefully you will be watching the next one as well. So thank you if you watch the whole video. Just be sure to maybe like it, subscribe, or just leave a comment below. So thank you, and until next time.